All right, so today we are working on a new process called solving systems of equations by elimination. All right, yesterday we did substitution. Before that, we've done graphing. We've now got our third method, which is called elimination. All right, elimination works best when both equations are in standard form. It just really does. All right, so if you've got one in standard form, one in slope-intercept, convert that slope-intercept guy into standard form, and then we can go from there. All right. Starting out with, let's look at our steps. Step one, you must have opposite coefficients on either the x or the y. Let's remind ourselves what a coefficient is. Remembering that a coefficient is the number that's in front of the x or the y. So looking down here at example number 1, 3 is a coefficient. Negative 7 is a coefficient. Negative 3 is a coefficient. Positive 4 is a coefficient. All right, all these numbers in front of the x's and the y's are coefficients. All right, next. What does it mean to have an opposite coefficient? That means they are the same number, but opposite signs. All right, and it's talking about having opposite coefficients on either the x or the y. All right, so let's take a look at example number 1 again, and we're going to see a very clear example of exactly what that means. Notice here I have a positive 3x, positive 3, and then I have a negative 3x. All right, same number, opposite signs. One's positive, one's negative. These are opposite coefficients. This is what we're looking for. All right. If we do not have that, it may be necessary, that's what step 2 here is, to multiply one or both equations to make the equations opposite, to make them have opposite coefficients. More on that when we get to example number 2. All right, step 3, add the equations and solve. Step 4, plug the value into one of the equations and solve, and then write your solution. Okay. As always with algebra, the steps sound a little more confusing when you're reading them than they do when you're actually doing them. So let's get into the actually doing them part. All right, we've already discussed that we do indeed have opposite coefficients here in front of our x. So we've done step 1, step 2 is not needed. Right here, we're at step 3. Add the equations and solve. Literally, guys, we're going to add these together. So plus, draw a line. All right. And we're literally going to add them up just like a very big giant addition problem. All right, so starting with the right-hand side, 10 plus negative 4 is 6. Bring down my equal sign. Negative 7y plus 4y. Well, that's negative 3y. All right, and now we get to the part where it's why it was important to have opposite coefficients. Positive 3x plus negative 3x. Well, a positive 3x and a negative 3x, they cancel each other out. I have no more x's. All right, I have just eliminated my x's. That's why this is called solving by elimination. So literally all I have left is my y variable. Now that I just have y left, I can solve for y. So to get y by itself, I'm going to divide both sides by negative 3. So that gives me y equals negative 2. Now that I know what y equals, I'm going to plug it into one of my original equations. It does not matter which one. We just generally want to pick the easiest one. In this case, it doesn't really matter either way. So I'm just going to plug it into the top one. All right, so plug it into the top one. I get 3x minus 7 times negative 2, we're plugging that in for y, equals 10. All right. Let's finish our math. 3x, negative 7 times negative 2 gives me a positive 14 equals 10. Then our x's by themselves, so minus 14, minus 14. Excuse me. 3x equals negative 4. So x, divide both sides by 3, guys. So x equals a negative 4 thirds. Remembering what we've been saying all along, the solution to a system of equations is a point, it's a coordinate. So we don't just want to say x equals y equals, we actually want to put this as a coordinate. So our x coordinate is negative 4 thirds, negative 2. It is absolutely okay that we got a fraction. All right, don't let that fraction freak you out, guys. It is absolutely fine. We are allowed to have fractional coordinates. We're fine. All right, this is Algebra 2. It's not 8th grade math. All right, going back, let's look at example number 2. All right, so step 1 is we must have opposite coefficients on either the x or the y. Looking at this, do we have opposite coefficients? No, right? We got close. I've got a positive 5 and a positive 5y, right? So this is where we're going to talk about the next step, that if needed, multiply one or both of the equations to make the opposite coefficients. All right, so I want one of these to be positive, one of them to be negative. How do I do that? If they're both positive, how do I make one negative? I can multiply the entire equation times -1, right? And if I multiply everything times -1, that changes the signs of everything. All right, so let's do that. Changes the signs of everything. So that makes this a -2x, a -5y, and a +9. All right, and then I can go to my next step, which is add the equations and solve. All right, so -4 plus 9 gives me a +5. +5y plus -5y is 0 y's. They cancel each other out. And 3x plus -2x leaves me with just 1x. Well, that was super easy, wasn't it? X equals 5. All right, so let's take this guy and we're going to plug him back into one of our original equations. I'll just use the top one. Scroll down and give me some space here. So 3 times 5 plus 5y equals -4. So 15 plus 5y equals -4. Subtract 15 from both sides. So I get 5y equals -19. So y divided by 5 equals -19 fifths. Once again, we got a fraction. Once again, that's okay. All right. Remember, our solution is a coordinate. It's a point. So let's plug these in. 5, -19 fifths. All right. I also want to make a note here. You can plug these into Desmos. It will graph it, and you can see where it crosses. The only caveat I have for that is these fractional ones, this -4 thirds, this -19 fifths, it will not give you a fraction. It's going to give you a decimal, okay? So make sure you got a calculator handy so you can convert your fraction to decimal form to see if Desmos agrees with you. All right, we have 2 more examples here. Let's work on these. All right, so step 1 is I need opposite coefficients. Do I have opposite coefficients anywhere here? No. So I'm definitely going to have to do some multiplication to get opposite coefficients. This time, though, I don't even have the same coefficients, right? So I can't just multiply one equation by -1. I'm going to have to do something bigger than that. So what we're going to do here is we're going to look at all my coefficients and see if any of the coefficients are factors of any of the other ones. Let me show you what I mean. So let's look at the x. I have a 3x and a 5x. Is there anything I could multiply 3 by to make it 5? No. Is there anything I can multiply 5 by to make it 3? No. Okay, so we're not going to mess with the x's. Let's go to the y's. I have a 3y and a -9y. Can I multiply 3 times anything to make it 9? Yeah, I could totally multiply 3 times 3 and make it 9, right? And then if that was a +9y and this is a -9y, I then have opposite coefficients. Yes, okay. So that's what we're going to do. Now remember, because this is an algebra equation, I can't just multiply the y, right? I have to multiply the entire equation by 3. Otherwise, I change what the values are and then it's no longer true. So let's multiply everything times 3. So that's going to give me 9x plus 9y equals -45. All right. Now we can add it and solve it. So -45 plus 3 going to give me a -42. Positive 9y plus -9y cancels each other out. 9x plus 5x gives me 14x. So I get 14x equals negative 42. I'm going to divide both sides by 14. So I get x equals 3. And not just 3, but negative 3. All right, so x equals negative 3. I need to plug this back into one of my equations and solve for y. Let's just plug it into the second one here. So 5 times negative 3 minus 9y equals 3. 5 times negative 3 is negative 15 minus 9y equals 3. Scrolling down. We're going to add 15 to both sides to get that 9y by itself. So negative 9y equals 15, 16, 17, 18. Copy it back up here because I'm running out of space. Negative 9y equals 18. Let's divide both sides by negative 9. So I get y equals negative 2. All right, once again, our answer is a point. It's a coordinate. So let's plug these guys in. So my coordinate is negative 3, negative 2. All right, last example. And this is a very good one because sometimes you can't just multiply one equation. What do I mean? All right, well, let's look at it. First step is we want to look for opposite coefficients, right? Is there anything I can multiply 4 by to get 3? Can I multiply 3 by anything to get 4? No. Okay, what about 2? Can I multiply 2 by anything to get 5? No, not a whole number. Can I multiply 5 by anything to get 2? No. Okay, so there's no simple one way. All right, so think about this kind of like finding the common denominator when you're doing fractions, right? All right, so let's look at this another way. If I said 1/4 plus 1/3, right? We know we have to have a common denominator, but I can't put either of these in terms of the other. I can't make my 4 a 3. I can't make my 3 a 4. It doesn't work. So what's the smallest number that they both go into? Well, it's 12, right? Okay, well, we're going to do the same concept here, all right? And only instead of multiplying fractions and changing their denominator, I'm multiplying the entire equation so I can change the coefficients. Okay, so I want to make the coefficients in front of my x's 12s. Okay, so in order to make these 12s, what do I have to multiply my first equation by? Well, in order to get 4 to 12, 4 times what is 12? Well, that's 3. Okay, so I multiply this entire equation times 3. So this gives me 12x minus 6y equals, and I should be able to do this in my head, guys, but I'm not going to be able to. 16 times 3, 48. All right, so it equals negative 48. Pardon me while I use my calculator there. All right, next, go to the second equation. All right, what do I multiply 3 by to get 12? 3 times what is 12? Well, that's 4. Okay, so multiply the entire equation by 4. So 4 times negative 3x gives me negative 12x. 4 times 5y gives me a positive 20y equals 4 times 12, which is 48. All right, now I'm going to add these guys together. All right, we're just looking at the blue. All right, in fact here, let me do this here real quick. It's kind of scribble. We're going to temporarily white out our original equations here. All right, so they're not a distraction. All right, so adding these together, starting at the right, negative 48 plus 48, well, that's 0. That's a first. All right, negative 6y plus 20y, well, that is 14y. 12x plus negative 12x, well, those cancel each other out, so we have no x's. So I now have 14y equals 0. All right, but I don't care what 14y is. I want to know what y is. So I'm going to divide both sides by 14. So we know this gives me y equals what? What is 0 divided by anything? If we've got 0 on top of a fraction, it's just 0, all right? So y equals 0. And then we can plug that back into one of our original equations. In fact, let's do that. Let me unerase them here. All right, so which one do we want to plug y equals 0 into? Does it matter? Not really. Let's just pick the top one. All right, so 4x minus 2, that's a 2, times 0 equals negative 16. All right, so negative 2 times 0 is 0, right? So do I even need to write that? Not really. So I get then 4x equals negative 16. Divide both sides by 4. So I get x equals negative 4. All right, once again, solution is a point. Let's write it as a point, as a coordinate. So my solution is negative 4, comma 0. Once again, you can plug this into Desmos. Desmos should tell you the same thing. All right, guys, that is all for today. As always, email me if you have any questions. Good luck with your homework.